Hello everyone, in this video I'm going to discuss the example for function and graph. Given the function of f and g are as follow. So here we have the function of fx, which is x squared plus 1. And we have the function gx, which is equals to square root of x minus 1. State the domain and range of f and g so that they are one-to-one function. So my suggestion would be illustrate the situation in graph. Then only decide what is the domain and the range for the function f and g. So let's begin with the function fx. So in here, we have a quadratic graph. Refers to the situation, we have a x squared. So as we all know, x squared will be the U shape, and then plus with the 1. Automatically, the graph will be something like this. So here we have the function of fx, where we have x squared plus with the 1, and here we have value 1. So x-axis, y-axis. So it refers to the situation. As we all know, the domain for this case would be negative infinity until infinity. But for this situation, if the domain is negative infinity until infinity, it will be not the one-to-one function. So in order to make the situation become one-to-one function, the domain for the situation will be either negative infinity until 0, or start from the 0 until infinity. Which means that, so for this case, this would not be the answer, because if from the negative infinity until infinity, the function of f would not be the one-to-one function. Continue, we have the range for the f. By referring to the graph, we have the minimum value, which is the 1. So the answer will be 1 until infinity. Continue. Focus on the function of gx, where we have the square root of x minus 1. So step number 1 would be x minus 1 greater and equals to 0. So x will be greater equals to 1. Second step refers to the coefficient of x. If it's a positive, the graph will be towards the right. Now sketch the graph. So by referring to the situation, we have x greater equals to 1. So it means that if we substitute 1, we will have 0. Continue, the graph will be something like this. So we have the y-axis, x-axis, and this one will be the gx, square root of x minus 1. So by referring to the situation, the domain for the function g would be start from 1 until infinity. Then by referring to the graph, we have the minimum value, which is 0. So we have 0 until infinity. So that is the situation, the domain and the range for the function f and g so that they are one-to-one function. Next kindly refers to b. Find the composite function for f rho g. So means that we have the function g substitute into the function f. So the function of gx would be square root of x minus 1. Substitute into the function of f. So we have the square root of x minus 1 bracket square plus with the 1. Kindly simplify the situation. So we will have x minus 1 plus with the 1, and we have the function f. So f rho g is equals to x. Continue. Find the g rho f. So we have g rho f. So meaning that in here, substitute the function of fx into the function of g. So continue. We have g, the function fx, where we have x squared plus with the 1. Continue. Square root of, here we have the x, which is x squared minus 1 plus with the 1. So in here, we have square root of x squared for the function g rho f. So if we simplify the situation, we have the g rho f, which is equals to modulus of x. Next, the third one, so f rho g rho f. So if we observe the situation, we have the function f bracket g rho f. So kindly refers to g rho f, where we have this part. So the g rho f actually equals to the modulus of x. So substitute the modulus of x into the function of f, where we have the situation modulus of x square plus with the 1. So if we substitute the situation, by referring to the definition, as we all know, the square root of x squared represents the modulus of x, then we have the square plus with the 1. If we simplify the situation, we will have x squared plus with the 1. That is the function for f rho g rho f. So that is the composite function. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.